Alrighty, howdy folks. Let's start with chapter 2. The chapter 1 was just an introduction, and in chapter 2, this particular one is not very long. It's just a few slides to give you an introduction to something called cash flow diagrams, right? What is this about? Well, definition. That is such a mathematician's thing to do, you know. Always give definitions. The moment you mention a new topic, you start with the definition. Standard, like my professor walked into the class and goes, groups, that's the heading. And as soon as he said groups, we all knew what he was going to do. Definition. A non-empty set G with a binary operator star, G comma star forms a group if, and so blah, 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 you know. Anyways, so what is a cash flow diagram? It's a pictorial representation of cash inflows and outflows over a period of time. Cash inflows and outflows. Well, that kind of makes sense, right? Like when you invest some money, that is money going out. That's an outflow of cash from your uh, pocket. Pocket need not be physical pocket, but you get the idea. And then, as a result of your investment, you'd be raking in some big bucks. And so that is the inflow of cash, right? Now, when it comes to drawing this cash flow diagram, it depends on whose perspective this is being looked at. For example, if you're looking at it from an investor's perspective, that is you, the investor, then first thing is a segmented horizontal line is what you draw. Segmented, what in the world is that? Segmented means you're splitting this into time intervals 0, 1, 2, and that's the time scale. Depends on how long is your what is called planning horizon. That's a big term that you will learn. Basically, how many years is this cash flow diagram going to represent? Okay, so in this case, for simplicity, I have 2 years. T equals 0, T equals 1, T equals 2. And positive cash flows are above the time scale. If you receive any money, you represent it above the time scale. And stands to reason, negative cash flows will be below the time scale. Cool? Now, at time t equals 0, let's say spent or invested, both mean the same, right? Money is going out, so that's the outflow. This is, let's say, 4,000. How do you represent this? You represent this with an arrow pointing down. Cool. And you list how much it is, $4,000. You won't do this negative cash flow or expenditure in the parenthesis and all that. That is understood. I have put that only because I wanted to give you an explanation as to what happened there. Cool. Then, at time t equals 1 year, received $5,000. Not so bad at all. I mean, that's a good deal. And then, at time t equals 2 years, received 2,000. That's even better, right? Not just you just invested 4,000, but you got 5,000 in year one and 2,000. That's very good deal. Cool. So this is how you draw a cash flow diagram. Now, cash flow diagrams are an efficient way of getting an idea of cash flows and for comparing alternatives. So not only the moment you see the picture, you get an idea of what's happening. Hey, how much money is coming in, how much is going out. But also that you can look at two different cash flows and compare both of them. And as one of the things as engineers you will do is precisely that. Where? Why would I do that? Here is the idea. What if your boss tells you, hey, yeah, We are planning to buy a new road laying machine. You are civil engineers typically. And so we want to buy this road laying machine. Okay. I want you to do an analysis. There are three or four vendors. I want you to find out all the details from them, and I want you to make a presentation, you know, in a week from now or a month from now. And so, one of the things you should do is show the cash flow diagram for all the alternatives. Hey, boss, with the first one, we're going to be spending $1 million. But the good news is it can lay the road in a very short time, and so we would be getting money, we would be making money every year, so much money, and like that. And for the second one, it is not as expensive, but we'll be making reasonable amount of money. But instead of just simply talking like that, you can show numbers, and you can also show pictures, cash flow diagrams. That's the idea. So here I have picked a simple example. For instance, which of the two alternatives should we choose? Alternative A, the cash flow diagram looks like this, and alternative B, cash flow diagram looks like this, right? Now notice that is clearly two alternatives. Which one should we pick, right? Uh, hmm. What? Both of them have a 4,000 investment at t equals 0. Good. Both of them you get 5,000 and 2,000. 5,000, 2,000. I don't see any difference, man. Hmm. When are you getting 5,000? You're getting it at t equals 1. And at t equals 2, you're getting 2,000 according to alternative A. Whereas you're getting the same amount at years 2 and 3 respectively. Does that make a difference? Of course it does. What is the difference? Would you agree that alternative A is a better idea? What? Why? Because if you spend money, you want the money back as quickly as possible. You don't want to delay for 2 years to get the 5,000. You are getting it at t equals 1 itself. Man, this is definitely better, right? Considering all the other options. If you were getting 2 years, if you were getting 7,000 or 8,000, well, we need to figure out whether that's a good deal or not. But the way it looks, definitely getting money sooner, like an alternative A, is a better idea. So we should pick alternative A. And that's exactly what I'm saying here. Though the two alternatives appear to have same cash flows, by time value of money, alternative A is better since receiving money sooner is better. Cool? All right. Jane needs $2,000 to pay off her bills. She borrows this amount from a bank with plans to pay it back over the next 4 years at X dollars per year. Draw a cash flow diagram, 1 from the bank's perspective, 2 from Jane's perspective. Right? I think that's a fairly simple problem. Let's get on with it. From the banker's perspective, well, we got the time axis for over the next 4 years. You do something at t equals 0, and next 4 years, t equals 1, 2, 3, 4. That's what I represented. Good. Now, from the banker's perspective, Jane needs $2,000 and she borrowed it from the bank. So, what should we do at t equals 0? I'm sure you already said, bank is going to lose money at that time, man. So, we need to go 2,000 down. Yes, you are right. But then, what happens in the next 4 years? Each year, t equals 1, 2, 3, and 4, bank would be getting X dollars from Jane, right? So, there's an X at t equals 1, and similarly, there's an X at t equals 2, 3, and 4. So, this is the cash flow diagram from the bank's perspective. I think that's fairly straightforward. Good. From Jane's perspective, same time axis, and she gets money at t equals 0. So we'll show that as a positive cash flow. And then she'll be paying all that over the 4 years. So that's a negative cash flow pointing down. Cool. So cash flow diagrams. We need to get very familiar with this, and we will, because oh boy, we'll be using this cash flow diagrams over the next all the throughout the course. We'll be using cash flow diagrams big time. Cool. What else? Well, there is nothing else. Amigos y amigas, adios.